the day is that we're going to treat I like a variable. The only time that we are not going to treat I like a variable is if we come across an I squared. If I come across an I squared, what should I replace that with? A -1. So I'm going to treat I like a variable all day long unless I see an I squared, and then I'm going to substitute in a -1. So that is the only exception to that rule. Now, your book likes to put a lot of parentheses in these problems. So truly what we call these numbers are complex numbers. So complex, I don't have any more copies back there, but you can write it down for today and then add it back in later. So complex numbers are a combination of real and imaginary stuff. So do you see how this has a real and an imaginary? So this thing we consider one complex number because it's got both parts. They like to section them off with parentheses. They really don't need to be. So remember the first thing I did is wrote them without parentheses. And then we combined our like terms. We did 4 minus 6 to get -2. We did 2i plus -7i to get -5i. Now this one was a little trickier because there was a minus out front and I needed to distribute that in. So it made this a +2, it made this a -3i. 1 plus 2 is 3, -3i and -3i is -6i. So we're just basically adding like terms. Are you ready to carry on? Flip the page when you're ready. I think I'm going to have my highlighters out again today. Do you see how I was going through and highlighting like terms? I might do that again today. So if that helps you see things, I would grab out a couple highlighters. If you don't have any and you'd like some, I've got extras up here. So again, our rule of thumb on the back is the same as the front. We're going to treat I like a variable, except if we come across I squareds, and then we're going to replace them with -1s. Okay, so I is just like X. If you have something out front of parentheses, what is it asking you to do?
Multiply it into it.
Yes, multiply it in. And I heard somebody say the word distribute. Yes, correct. So let's multiply it in. 4i times 7 is going to give you what? 28 i's. Okay. 4i times -8i. Don't replace the I squared yet. I know we said we were going to. -32i squared. Okay, so again, this is just our normal, like what we do with algebra, right, to simplify things down. Now, this is where we've got to stop and deal with the I squared. What do we know I squared is really? So really what I have here is -32, and because I wrote 33. Don't know why, people. And next to it, I'm going to write times -1. Because remember, when you have two things right next to each other, they're being multiplied. Well, what is -32 times -1? 32. And this is my final answer. Now, typically, your book likes any complex numbers to be written with the real part first. So if you look at this answer in your book, it's going to say 32 plus 28i. It's always going to put the imaginary part second. That is not something I would mark wrong. Okay, they do like the real part first though in the book, so when you look at any of the answers, they're going to be in the flip order. But again, it doesn't matter to me. Another way to think about this, if you don't want to do this middle step, you don't have to. You can think of this as, the I squared's job is to change the sign, and then once it's done its job, it can disappear. That's another way to think of it. Good? Okay, let's go over here. That looks like some foiling, yeah? Let's foil. I actually oil is what I've discovered. I do first inner. Anyway. 3 times 4. 12. 3 times -i. 6i times 4.
24i.
24i. 6i times negative I.
Negative 6i squared.
Negative 6i squared. All right, perfect. How are we doing so far? Okay, I'm going to do two things in this step. Do you see how I have some like terms here sandwiched in the middle? Do we see them? Yes? And believe it or not, these are like terms. Because this is 12, and what is this really?
6.
Positive 6, exactly. All right. So, if I combine, again, the book likes the real part first, so let's make the book happy. If I combine these, 12 and positive 6 gives me 18. Negative 3i plus 24i gives me 21i. Boom, done. Ooh, something interesting, and again, I feel like when I use the word interesting in math, like it might only be interesting to me. Something interesting happens in the next one. Try the next one without me. I'm going to freeze my smartboard so you can't see it. You try the next one. You're still foiling. Something interesting happens. My definition of interesting, maybe not your definition of interesting. Mm-hmm. Mm-hmm. Yep. That's exactly the interesting thing I was thinking of. But again, like I said, I think my definition of interesting is not the same as everybody else's, which is fine. Bless you. All right, I've got my answer. I'm going to give you a second. Okay, ready? Here it comes. Yeah? Did we get the same thing? No? Oh, wait, this should have been negative. That's why. This should have been negative. That's why. Just kidding. So this will be positive, and this will be 85. Just kidding. I didn't get negative 77 either. I did that to show you. No, I didn't. Thank you. Appreciate your grace. All right, there we go. Now it's right. Okay. These look worse, but they're not as bad as they appear. Here's the thing. You can still have fractions, but there is a rule in math. Yep. Go ahead. There's a rule in math that the math police will come and get you if you leave an I in the denominator. So there are no I's allowed in the denominator. No I's allowed in the denominator. Now, you can still have fractions. That's fine. We're not mad at fractions. I mean, they're not my favorite, but you can have them. So I's are still okay, and fractions are still okay. The I's in the denominator, not okay. Now, there are two situations that you're going to encounter, so we're going to deal with both of them. Situation number 1. So this right here is situation number 1. Do you see how you have one term in the denominator? Do you agree with me? Yes, no? If you have one term in the denominator, you deal with it differently than if you have two terms. Do you agree these both have two terms? Yes. Okay, so we're going to deal with this one way. We have a different strategy. We're going to deal with these two the same way. All right, so if you have one term, the strategy is to multiply everything by I. So I call this kind of the Oprah strategy where everybody gets an I. You get an I. You get an I. You get an I. Everybody gets an I. So this is the strategy where we multiply everything by I. I'll show you why it helps. It seems like it wouldn't. Trust me that it does. All right, so I get 3I plus 10I squared all over 5I squared. Yep, the bottom's just going to have a -5. Do you guys agree with Jackson on that? In the top, I have 3I, and what am I going to put in place of this? Subtract 10. All right, now, you can leave your final answer like this. You could also mix around your signs, right? So I could make this negative, positive, positive, so that there were fewer negative signs, but this is a fine final answer. So you can box this in and call it a day. You could also, like I said, if you want to divide the negative out so there are fewer negatives, you could get -3I. This would become a +10, and this would become a +5. So that would be another acceptable answer. Bless you. Remember that the book likes the real part first. You could also write it as 10 minus 3I over 5. So that way it's in that order. And sometimes your book is going to go this far. It's going to separate the fraction. So 10 divided by 5 is 2. And then this doesn't divide, so it's going to leave it as a fraction. So you could have, this is an answer, this is an answer, this is an answer, or this is an answer. They're all going to get full credit. Now, does one of them maybe look a little bit nicer than the others? Sure. This one looks less complicated, so that probably looks the nicest. And the way I usually say it is it reminds me of a car wash. If you go to the car wash, you know how you can get the good, the better, the best, right? Like the good, they just spray it with a hose maybe, I don't know. The better, they've got like soap, right? You actually get the soap that time. The best, they're like polishing and waxing and putting all this extra stuff on it. No matter which one you get, you're still getting a car wash, right? But one of them comes out looking just a little bit nicer. That's kind of how I feel about these answers, okay? We've got probably a good, better, best situation, but they're all going to get full credit. Does that make sense? So any of these are full credit, so you can write it however you'd like. The goal is to get rid of the I in the denominator. That is the goal. All right, look at part B. When you have two terms, we're going to multiply by something called the conjugate. Remember a minute ago when we did this problem and the middle terms canceled out? The reason they canceled out is because it was the same set of parentheses twice, but the signs were switched. So here what we're going to do is we're going to multiply by the same thing, but we're going to switch the signs because it's going to help stuff cancel out. In a fraction, I can multiply something to the bottom as long as I also multiply it to the top. And we call these conjugate pairs. So if you have the same thing twice, except your signs change, right? One's negative, one's positive. We call those conjugate pairs. We're going to multiply it out. This is another moment where at first it's like you're making it worse. That's true, but it's going to get better. 2i times 4 is going to give me what? 8i. 2i times 3i. All over. Look at the bottom. 4 times 4. 16. 4 times 3i. Oops, I wrote 21. I don't know what's wrong with me today.
Nothing's wrong.
Aww. Jackson, you need to stay here the rest of the day and tell me good things. That's your new job.
I'll stay here the rest of the day. As long as they don't get
Oh, stop. All right, so we got 12i. Negative 3i times 4, what's that going to give me? negative 12i. Negative 3i times positive 3i.
Negative 9i squared.
Negative 9i squared. Do you see how those middle two terms are going to cancel out in the center and the denominator? That will always happen. We planned it that way. That was a part of our evil master plan. All right, in the top, this is going to stay 8i. What is this going to become, though? Negative 6. All over. This is 16. What is this really?
9.
It's going to be a positive 9, yeah? 9 plus 16?
25.
25. Now, you need to take a step back with all of these and make sure that it's as reduced as possible. So if you can reduce, you should. Is there something that divides evenly into all those things? Like 3 or 2 or 7, I don't know. Is there anything? No. Sometimes there will be, and you should reduce. Now, could we go back to our math car wash and rewrite it so that these two things are flipped? So it says negative 6 plus 8i over 25.
Yeah.
Would that be an okay answer? And I could even separate the fractions, right? So there are other options for how to write this. This is fine, and you can be done here. All right, look at part C. Same issue. We have two terms, so we need to multiply by the conjugate. In this case, what should I multiply by? 8 plus 2i. And if I do it to the bottom, I have to do it to the top. Here we go. We've got two FOIL situations. 5 times 8. 40. 5 times 2i. 10i. 3i times 8. 24i. And then 3i times 2i. Yeah, perfect. Okay, now, in the bottom, I get lazy and I don't FOIL, I fool. I take out the O and the L, because what's going to happen to your middle two terms always? They're going to cancel, so why am I going to waste my time with that? I've got other stuff to do. 8 times 8 is?
16.
And then negative 2i times positive 2i is?
Negative 4i squared.
Negative 4i squared. So I'm going to take a shortcut and I'm just going to fool, because the middle two terms are always going to cancel out. We planned it that way. All right, let's start combining stuff. In the top, this 6i squared is really what? Yeah, negative 6. So again, if we think about like terms, in this middle section here, I've got those are my like terms. This 40 and this minus 6 are like terms. I'm not going to highlight this because this negative 6 is really this guy right here. And in the bottom, I really have what? 64 plus 4. All right, so let's simplify that mess of stuff out. I'm going to do this first. What do I get with my plain old numbers on the top? 34. How many i's do I have? 34. In the bottom, I get?
68.
Okay. Now, pause, take a step back. Can I reduce all those numbers?
Plus 1i over 2.
So what divides into all of them? 34. Do we agree 34 divides into everything? So I'm going to divide everything by 34. Okay. In the top, 1 plus 1i over 2. This is a lovely answer. I could also flip the order. I could also, again, remember there are different combinations of things that could happen. Friendly reminder. Let's say I had this instead. Let's just pretend together for a moment. Well, this can still be 68. Can I reduce that?
No.
No. So if two things work, that's great, but all three of them have to work for me to truly reduce. Now, I could do 34 over 68 and 33i over 68, and then I could reduce this part. That'd reduce to 1/2. Again, you don't have to do that though. So if I encountered something like this, I would be done. Does that make sense? Again, you could keep going, but you don't have to. So remember, in order to do what I did here, it truly has to divide into everything evenly. Are we ready to try some problems on our own? Okay. We are on, I don't think it's assignment 3. I think we're on assignment 4. Page 165, numbers 25 to 37. I'm going to double check those because they have some in there that I don't like sometimes. So let me triple check before we get started, but that is tentatively the homework. Now, chapter 3 has too much stuff in it, in my opinion. Also, when Mr. McKinney had the class originally, he was giving a lot of quizzes and not as many tests. So what I do with chapter 3 is I give 2 big quizzes instead of a quiz and a test. Okay, so there will not be a chapter 3 test. We're going to review and we're going to take the quiz, and then that kind of bookends this first part. And then we're going to learn more of chapter 3 and review and take a quiz. They're going to be a little bit larger quizzes, but still count as a quiz grade. So in that way, it'll weight a little bit heavier on your grade, but they're going to still be in that quiz category. Does that make sense? If it doesn't, make sure you ask me questions about it, and I can try to figure a way to explain that better. Oh no, my book. All right. Let's see. 25 to 37. No, I do like all of them. Just kidding. They're beautiful. No. Do I? I don't like 34. We don't need to do the formula. So don't do 34, but do the rest. So 25 to 37, but don't do 34. Good? Okay. Here's kind of the interesting part. Has anybody ever thought about being an electrician?